Welcome. Today we'll explore absolute value functions, one of the most fascinating topics in algebra. Let's start with the big question. What is absolute value? Absolute value measures the distance of a number from zero on the number line. Distance is always positive, so absolute value is always non-negative. Let's look at some examples. The absolute value of 5 is 5, because 5 is 5 units away from 0. The absolute value of -5 is also 5. Even though -5 is on the left side of 0, it's still 5 units away. The absolute value of 0 is simply 0, and -3.7 has an absolute value of 3.7. Remember this key insight. Absolute value is always 0 or positive. It can never be negative. Let's visualize this on a number line to make it crystal clear. Here's our number line with 0 right in the middle. The number 3 is located here, 3 units to the right of 0. So the absolute value of 3 is 3. Now look at -3. It's on the left side, but it's also exactly 3 units away from 0. So the absolute value of -3 is also 3. This is the key idea. Both 3 and -3 are the same distance from 0. Absolute value ignores the sign and just gives us the distance. Now let's see what happens when we graph the absolute value function. Here's our coordinate plane with x and y axes. We'll graph y equals the absolute value of x. For negative x values, the graph goes up to the left. For positive x values, it goes up to the right. This creates a beautiful V shape. The point at the bottom of the V is called the vertex. For the basic absolute value function, the vertex is at the origin, the point 0, 0. This V shape is the signature of every absolute value function. Now let's understand why the graph has this V shape by looking at the piecewise definition. The absolute value function is actually made of two pieces. When x is 0 or positive, the absolute value of x equals x itself. But when x is negative, the absolute value equals -x, which flips the sign to make it positive. Let's see these two pieces on the graph. On the right side, where x is positive or 0, the graph is simply y equals x. This is a straight line going up to the right. On the left side, where x is negative, the graph is y equals -x. This flips the negative x values to positive y values, creating the other arm of the V. Together, these two linear pieces meet at the vertex to form the iconic V shape. Now let's learn how to move the V shape up and down. This is called a vertical shift. Here's our coordinate plane. Let's start with our base function, y equals absolute value of x. When we add 2 to the function, the entire graph shifts up by 2 units. The vertex moves from 0, 0 to 0, 2. When we subtract 2, the graph shifts down by 2 units. The vertex is now at 0, -2. Here's the rule. When k is positive, the graph shifts up. When k is negative, it shifts down. Simple. Next, let's learn about horizontal shifts, which move the graph left or right. Here's our coordinate plane with a wider view. Again, we start with y equals absolute value of x, with its vertex at the origin. Now here's something tricky. When we write y equals absolute value of x minus 3, the graph actually shifts right by 3. The vertex moves to the point 3, 0. And when we write x plus 3, the graph shifts left by 3. The vertex is now at -3, 0. This is a common source of confusion, so remember, the shift is opposite to the sign inside the absolute value. Minus means right, plus means left. Now let's put it all together with the vertex form. the most powerful way to write absolute value functions. The vertex form is y equals a times the absolute value of x minus h, plus k. Each letter controls a different aspect of the graph. The value a controls stretching and reflecting. The value h shifts the graph horizontally, and k shifts it vertically. The most important insight: the vertex, which is the turning point of the V, is located at the point h, k. This makes graphing much easier. For example, in y equals 2 times absolute value of x minus 3 plus 1, we can immediately see that h is 3 and k is 1. So the vertex is at the point 3, 1. What happens when we put a negative sign in front of the absolute value? Let's find out. Here's a coordinate plane that shows both positive and negative y values. Our original function y equals absolute value of x opens upward, like a valley or a smile. When we add a negative sign, we get y equals negative absolute value of x. This flips the entire graph upside down. Now it opens downward, like a mountain peak or a frown. This is a reflection over the x-axis. Every point on the original graph gets mirrored to the opposite side of the x-axis. The value of a also controls how steep or wide the V shape is. Let's compare different values of a. Here's our base function where a equals 1. When a equals 2, the graph becomes steeper and narrower. This is called a vertical stretch. The V shape is squeezed in toward the y-axis. When a equals 1/2, the graph becomes wider and flatter. This is a vertical compression. The V shape spreads out. To summarize, when the absolute value of a is greater than 1, the graph stretches and becomes steeper. When it's less than 1, it compresses and becomes wider. And remember, if a is negative, it also reflects over the x-axis. Now let's put all the transformations together in one example. Consider the function y equals negative 2 times the absolute value of x plus 1 plus 3. Let's break this down. The value a equals negative 2, which means we reflect over the x-axis and stretch by a factor of 2. Since x plus 1 is the same as x minus negative 1, h equals negative 1, so we shift left by 1. And k equals 3, so we shift up by 3. Let's see the result on a graph. The faded green line shows our original function for reference. And here's our transformed function. Notice how it opens downward because of the negative sign. It's steeper because of the 2, and the vertex has moved to the point negative 1, 3. Finally, let's learn how to solve absolute value equations. Here's the key rule. If the absolute value of x equals a, then x could be either a or negative a. That's because both values are the same distance from 0. Let's solve absolute value of x minus 2 equals 5. We split this into two cases. In the first case, x minus 2 equals positive 5, so x equals 7. In the second case, x minus 2 equals negative 5, so x equals negative 3. So we have two solutions, x equals 7 or x equals negative 3. Look at this on a number line. Both solutions are exactly 5 units away from the point x equals 2. That's the beautiful symmetry of absolute value. Let's wrap up with a quick summary of everything we've learned. Absolute value measures distance from 0. The graph of y equals absolute value of x is a V shape. The vertex form lets us identify transformations easily. The vertex is at the point h, k. A positive opens up, negative opens down, and the size of it controls how steep or wide the V is. The V shape is the signature of the absolute value function. Practice these transformations and you'll master absolute value functions in no time. Thanks for watching.